Bismillahirrahmanirrahim. Today we are going to speak about the vectors in 2 and 3 spaces. Starting with the definition, what do we mean by a vector? A vector is a quantity that has magnitude and direction. Or sometimes we say it is a physical quantity that has magnitude and direction. A vector is quantity that has magnitude and direction. And usually represented by an arrow. Vectors usually it has start point and end point to create a vector. And the differences between these 2 points will give me the component of the vector. So this will be the second definition now. Let A, or okay, let A, and this is the notation for the vector A, and we draw an arrow up that one or above that one. Let A be a given vector. With initial point. Be x1, y1, and terminal point. Q, x2, and y2. Then the coordinate differences a1, which is equal to x2 minus x1, and a2, which is equal to y2 minus y1. The differences between the coordinates starting from the terminal point to the initial point. x2 minus x1, y2 minus y1, or we can say q minus b. We just find the differences between the terminal and the initial point are called the component of the vector. These differences components of the vector I, which is the notation written or given by this one. It is a1 and a2. So the vector A given by this notation, two brackets or bigger and smaller signs, is equal to A1 and A2, where A1 is the differences, or the difference between the X coordinate and Y, and A2 is the difference between the Y coordinates. But we have to notice the direction. So from the terminal point to the initial point. And the magnitude given by this notation. This norm notation or magnitude for a vector given by A1 square plus A2 square. So this is the definition for a vector into space. It has two components, A1 and A2. A1 is the difference between the X coordinate, Y, and A2 is the difference between the Y coordinate. From the terminal point to the initial point. For example, let's take this example. Find the vector P1, P2. P1 to B2, it means that the initial point is B1, the terminal point is B2. While B1, so this is the first one, is given by 3 and 6. B2 is given by 5 and let's say 8. Now the vector B1 to B2 is equal to, it is x2 minus x1, this is the first component, and y2 minus y1. X2 is equal to 5 minus x1 is 3, y2 is 8, okay, this is x1, y1, x2, y2, it is 8 minus 6, which is equal to 2 and 2. So the vector is 2 and 2. The first component is 2 and the second component is 2. If we need to find the magnitude, if the question says find the magnitude, then the magnitude B1 to B2 is equal to square root of 2 square plus 2 square, that will be equal to square root of 8. The magnitude for this vector is equal to 8. Another example. Suppose that B1 is 1, 0, and 4. This is in the three-dimensional space. It has three coordinates, x, y, and z. B2, say 5, 2, and 1. The vector B1 to B2 is equal to, in this case I have three components. I have A1, A2, and A3. We have the difference between x coordinate, y coordinate, and z coordinate. So the first one, this will be x1, y1, z1. This is x2, y2, z2. So it is 5 minus 1. This is the first component. Or I can write it in two steps. It is x2 minus x1, y2 minus y1, z2 minus z1, which is equal to 5 minus 1. y2 is 2 minus 0. z2 is 9 minus 4. Which is equal 5 minus 1 is 4, 2 and 5. Now the magnitude for this one is equal to square root of, in this case, a1 square plus a2 square plus a3 square. Just square the components. That will be 4 square plus 2 square plus 5 square, which is equal to square root of 16, 20, this is 45. So the magnitude for this vector is equal to 45. Using these concepts, sometimes we need to find either the terminal point or the initial point. In some cases, the terminal point is not given, or the initial point is not given. For example, find the initial point of the vector is equal to minus 5 minus 1. F point is 4 and 7. We need to find the initial point. We have the terminal point 4 and 7, and we have the components of the vector. V1 to V2 is equal to minus 5 and minus 1. But this is equal to x2 minus x1, y2 minus y1. So the terminal point minus the initial point, which means minus 5 equal to x2 minus x1, and minus 1 equal to y2 minus y1. Now x2 is the x coordinate of the terminal point, which is this, it is equal to 4. y2 equal to 7. So minus 5 is equal to 4 minus x1. So x1 will be 9. This is a linear equation, easy to be solved. Now to find y1, I have minus 1 equal y2 is 7. 7 minus y1, so y1 will be 8. So the initial point in this case V1 is given by 9 and 8. It is 9 and 8. For the initial point, if the initial point is the origin point in the xy coordinate, in that case we call the vector is standard position vector or position vector. Position vector the vector given by OB. That is only, okay, I can cut x1 and x2 or x1 and y1, where O is the origin point. So any vector start from the origin to some point, we call this is a position vector. This is the initial point. So any vector start at the origin is called a position vector. Now the vectors, whatever it is in the position, or it is any general vector, let's say the vector, or speak about the basis. The triple vector I, J, and K. This set called a standard basis. For of three-dimensional space, where I is 1, 0, 0. J is the vector 0, 1, and 0, and K is equal to 0, 0, and 1. So this triple is just standard basis for the three-dimensional space R3. It means that any vector in the three-dimensional space can be written as a combination of I, J, K. This is the meaning. For example, the vector A. Okay. Yeah. This means any vector in R3 can be written as a linear combination of the bases. For example, the vector, let's say B1, B2, given by 5 minus 2 and 3. This can be written as 5i, 5 multiplied by I, minus 2 multiplied by j, plus 3k. This is the meaning of basis. Any vector in the three-dimensional space, it will be a combination of the standard basis, I, j, and k. If it is in two-dimensional, I don't have k, it will be only I and j. So these are the standard basis for the three-dimensional space. I will be in the x-axis, j the y-axis, and k in the z-axis. If we have a three-dimensional, in three-dimensional, this is z, y, and x. This will be I, this is j, and this is k. X, y, z. And you will notice also all the magnitude of these standard vectors are the same, equal to 1. Any vector with magnitude equal to 1, we call it a unit vector. For example, that if I have B2 in two-dimensional case, let me say 7 and minus 3, this will be equal to 7i minus 3j. If you are speaking about the vectors in the two-dimensional space. So this is the idea of the vector. It is just a physical quantity with magnitude and direction. And it is the difference between the terminal point and the initial point, so that we can find the components. We have the magnitude, and we can write any vector using the standard basis of the space, either in two-dimensional case or in three-dimensional case.